is, you said that there is infinite information within elementary particles. Can you just explain that a bit more? And the second one is, with quantum technologies, how exactly would we stop any information losses because of just randomness in the quantum world?
Great questions. So can I answer this?
Great ahead if you can.
So yeah, I made an attempt to answer your first question, to explain the difference between digital and quantum by saying in digital the fundamental concept is 0 or 1. So if you look in your laptop or computer, all you will find there is a vast number of storage elements, each one of which can either be 0 or 1. And there's nothing more to digital information. A bit is 0 or 1, a byte is 8 bits, and we know we measure storage in a computer in megabytes or kilobytes, 1,000 bytes or a million bytes, and that's all it's talking about. What I also said is quantum world doesn't work in bits. The simplest thing you can find in nature is an elementary particle, like an electron. It has many properties, one of which is its position. It can be in different places. That's not a 0 or 1, that's a continuous thing. That's an analog piece of information. But it has an even simpler thing, which is its spin. So an electron spins. You can kind of think about it like a spinning ball of charge, but because it's a quantum spin, it turns out if you measure it, you can only get one of two results. When I measure it, the spin around some axis, either it's going clockwise or it's going anti-clockwise at the same fixed rate. So that is the simplest possible thing in nature, is the spin of an electron. And as I said, you might say either it's a 0, either it's clockwise or anti-clockwise, just two options. Looks like a bit, but that's not true. The spin of an electron can be simultaneously both clockwise and anti-clockwise in some proportion. So it can be 99% clockwise and 1% anti-clockwise, for example. And those two numbers tell you the probability of actually getting clockwise or anti-clockwise if you measure it. But it's even richer than that. Okay? That the state of a spinning electron, if you try to describe the most general possible state for a spinning electron to be in, it's actually described by a sphere. And I can't really explain this without imaginary numbers, but basically the state of just one electron spin is equivalent to the position of a point on a sphere, on a two-dimensional sphere like the sky. And so if you just look at an electron, the simplest thing in nature, it's a whole sky. In fact, it's pretty amazing that the simplest thing in nature has the information storage capability of a star with a point of light on it, with a star on it. And I hope that gives you an impression of how unbelievably rich the natural world is. So a sky is two-dimensional, and that's what one spin contains. If you have two electron spins, you get a four-dimensional sky, which is a very big place. In three electron spins, you get a six-dimensional sky. And four electron spins, and so on. And 300 spins, you get 2 to the power 300 dimensional sky. It's a huge place to store information. And that's why it contains all same amount of information as you would have in the position of every particle in the whole universe. So that's somehow what you're looking at when you look at a quantum computer. It's really amazing.